This is your test review for Test 2A. Your test is on Thursday, September 26th. The first problem has you find the GCF and the LCM for the number set of 20 and 35. Okay, remember there's a couple different ways you can do this. If you want to find the GCF, you can make your rainbow and find the factors, or you can use prime factorization. To find the LCM, you can make a list of all the multiples, or to do both at once, you can make your ladder. For this review, I am going to do the ladder method because it is the method that gives you both answers in one step. So if you're doing the other methods, that is fine. Your GCF and your LCM should be the same no matter what. So if you're using the other methods, check your answers against what I get for the GCF and what I get for the LCM. So let's go ahead and get started. Number 1, my number set is 20 and 35. Okay, and I need to think of a prime number that goes evenly into 20 and into 35. And I'm going to pick 5. 5 goes into 20 4 times, and 5 goes into 35 7 times. So then I ask myself if there's any prime number that goes evenly into 4 and 7. And there is not. So my GCF is 5. In my LCM, remember, you draw your L. And my LCM is 5 times 4 times 7, which is 140. Okay, notice how I'm showing my work up here. On your boxes, on your review sheet, this is the amount of work that I expect to see in those boxes. Alright, number 2, you're finding the GCF, the greatest common factor, and the least common multiple for 34 and 10. So for 34 and 10, I'm going to make my ladder. Okay, and then I ask myself what number goes evenly, what prime number goes evenly into 34 and 10. I'm going to pick 2 because they're both even numbers. 2 times 17 is 34 and 2 times 5 is 10. Then I ask myself, is there any prime number that goes evenly into 17 and 5? And there is not. So 2 is my GCF, and my least common multiple is 2 times 17 times 5, which is 170. Again, notice how much work I have in these boxes. In your boxes on your worksheet, that is the work that I should see in your boxes. Oops, what did I do? There it is. Alright, next one. I just did it again. Next one, I'm finding the GCF and the LCM for 25 and 105. Okay, so I'm going to write 25 and 105, and I'm going to think of a factor, a prime number that goes into 25 and 105 evenly. And the number that I think of right off the bat is 5. 5 goes into 25 5 times, and 5 goes into 105 21 times. Now I think to myself, is there any prime number that goes evenly into 5 and 21? And there is not. So my GCF is 5, and my least common multiple is 5 times 5 times 21, which is 525. I should see this amount of work in your boxes on your review sheet. Oops. Next question, you're finding the GCF and the LCM of 20 and 60. So I write my 20, my 60, make my ladder, and I'm going to think of a prime number that goes evenly into 20 and 60. I'm going to start with 2, and I get 10 and 30. Then I ask myself, is there another prime number that goes evenly into 10 and 30? And there is. It's 2 again. 2 times 5 is 10. 2 times 15 is 30. Then I ask myself, is there another prime number that goes evenly into 5 and 15? And the answer is 5. 5 goes into 5 one time. 5 goes into 15 3 times. There is no prime number that goes evenly into 1 and 3. So my GCF is over here, which is 2 times 2 times 5, which is 20. And my LCM is this whole area of the L. Think of L and LCM is 2 times 2 times 5 times 1 times 3. And that gives me 60. So your GCF is 20 and your LCM is 60. Next one, I have 15 and 55. So make my ladder, 15 and 55. My prime number that goes into both 15 and 55 is 5. 5 times 3 is 15. 5 times 11 is 55. And that's the only prime number that can go into those. So I'm done, and my GCF is 5. And my least common multiple, I got to draw my L. My least common multiple is 5 times 3 times 11, which is 165. Next one is 64 and 96. This is a bit of a long one, so I have 64 and 96. Okay, and what prime number goes into both 64 and 96? I'm going to pick 2. 2 goes into 64 32 times. 2 goes into 96 48 times. And there's another prime number that goes evenly into both of those, and that's 2. 2 times, or what times 2 is 32 is 16, and 24, and there we go, 24 times 2 is 48. And there's another prime number that goes in, it's another 2, and that gives me 8 and 12. I keep going, another 2, it gives me 4 and 6. And keep going, gives me 2 and 3, and then I'm finished because there is no prime number that goes into both 2 and 3 evenly. So my GCF is 2 times 2 times 2 times 2 times 2, which is 2 to the 5th, which is 32. And my LCM is 2 times 2 times 2 times 2 times 2 times 2 times 3. So it's 2 to the 6th times 3, which is 192. Your GCF is 32 and your LCM is 192. Next one, turning over the page. You're finding the GCF and the LCM for 72 and 45. So I'm going to draw my ladder of 72 and 45. My prime number that goes in is 3. 24 times 3 is 72, and 15 times 3 is 45. My next prime number that goes in is another 3. 8 times 3 is 24, and 5 times 3 is 15. There is no prime number that goes into both 8 and 5 evenly, so I'm finished. My GCF is 3 times 3, which is 9, and my LCM is 3 times 3 times 8 times 5. 3 times 3 times 8 times 5, which is 360. So again, no matter how you choose to do this, whether You choose to find the GCF using prime factorization or the factor lists, or you choose to find LCM with the lists, you're always going to get the same answer. Alright, this is when I'm going to throw in your bonus question for watching this video. So here is what you need to look up. Pi in math is considered 3.14. Your job is to figure out what day of the year Pi Day is celebrated on. Again, pi is 3.14. And that's the short version of pi. What day of the year do mathematicians celebrate Pi Day? Alright, moving on. Now we're moving on to three numbers. We are moving on to three numbers. We have 20, 50, and 100. What prime number goes into 20, 50, and 100? I'm going to start out with 2. Oops. Okay, and 2 goes into 20 10 times, 2 goes into 50 25 times, and 2 goes into 150 times. Then I'm going to pull out a 5, and that's going to leave me with 2, 5, and 10. And here is the tricky part. I asked myself, is there a prime number that all three of those numbers can evenly go into? And there is not. Okay, there's not a prime number that 2, 5, and 10 can evenly divide into. So I know right away that 5 over 2 is my GCF. So I want you to stop what you're doing in this problem, go over here, and write your GCF is 2 times 5, which is 10. Okay? But you have to keep going to find the LCM. Then you ask yourself, if there's not 3, you need to ask yourself, are there 2 numbers that a prime number could evenly go into? And there are. Okay, 5 and 10. So if I divide 5 again, my 2 stays. 5 goes into 5 one time, and 5 goes into 10 2 times. Okay, but I'm still not done, because there is a prime number that will still go into 2 of these numbers, and that's 2. So 2 goes into 2 one time, I bring down my 1, and 2 goes into 2 one time. So now I'm finished, and my LCM is all of this. You include your GCF. Okay, don't do crazy stuff and make this 2 times 5 times 5 times 2 your GCF. You're done with your GCF when all 3 of your digits aren't divisible by your prime number. Okay, so my LCM is 2 times 5 times 5 times 2 times 1 times 1 times 1. And that gives me the answer of 100. So my GCF is 10 and my LCM is 100. Next problem, 16, 40, and 80. Okay, what prime number am I going to start with? I'm going to start with 2. So 2 goes into 16 8 times, 20 times, and 40 times. Then I'm going to go with 2 again. And I'm going to get 2 goes into 8 4 times, 2 goes into 20 10 times, and 2 goes into 40 20 times. I'm going to do 2 again. I get 2, 5, and 10. And I'm going to do it, and then I'm going to stop because that's my GCF. So my GCF is 2 times 2 times 2, which is 8. But I have to keep going for my LCM, and I'm running out of time in this video, so I'm going to hurry in. So I'm going to take a 5, go down, this is going to stay, 2, 1, and 2. My LCM is all of this, and my LCM is 2 times 2 times 2 times 5 times 2 times 1 times 2, which gives me the LCM of 80. Alright, part 2 of this video will be next.